All right, let's begin. Hello, everybody. Thanks for attending this session on Diagnostics and Troubleshooting using Azure App Service Support Center. My name is Shekhar.
And I am Praveen.
We all have our applications on cloud. I have my application on app services. $1 million question whenever we use cloud is, what should we do when our application goes down? Is there enough transparency provided by the cloud providers which will help my application, which can help me debug my application when production is having issues? How many of us have woken up 2 a.m. in the morning trying to do the same thing, trying to debug my production application? There we go. Yes, a lot of people. What do you think, Praveen?
Oh yeah, I totally agree. I think production down is a very, very tough situation, especially for people who are dealing with the incidents. The stakes are high, the time is of essence, and people all around you are expecting you to solve the problem rather quickly. Now, even so, if all of us are placed in a similar situation, most of us do not know what are the logical steps that we need to take to bring the production back up. So today we're going to share with you guys a formula of 4 steps that will help you navigate through this tough situation of production down. All you got to do is keep your emotions away, follow the steps of 4, and I'm sure you will land in a better situation. So here we go. The formula is as follows. Step number 1, this is the easiest one. You check for the platform health. Is Azure in general working fine? It's fairly easy to check. Go to status.azure.com, and if there is something wrong, you will know. Step number 2 is you check for resource contention. Is your app running on high CPU, or is your app running on high memory or threads? It's fairly easy to find this out, and we'll show it to you in a couple of minutes. Step number 3 is you look for, has there been any recent changes to your app? Has there been any configuration changes, or has there been any recent deployment that one of your colleagues have done? And if the recent changes are correlating with the downtime, then you got a hit. And fourth and the final step is you look for your application-specific errors. If there are exceptions happening in your code, that will show up in your application log files. There you go, folks. These are the 4 simple steps that you can use to navigate through the tough situation. Now, if you're hosted in cloud or if you're hosted in Azure, you can use this formula for the benefit. However, if you are hosted on app services, then we have done something very special for you. What we do is we run the formula automatically for you and present its finding on a platter. All you have to do is visit our support center, and you will be equipped with all the information that you need in dealing with these kind of tough situations. So, Shekhar, can we talk about the support center and maybe with an example or two on how we are supposed to use it?
Yeah, sure. I think let's just jump to the demos. All right. I have a production app. It's a WordPress app, PHP app. A lot of you are aware of the PHP stack. That's one site nobody loves, right? That's one of the most hated page in the web world. If you keep refreshing this, that's very embarrassing. All right, so let's try to debug this application using Support Center. So what we need to do is we need to go to Azure portal. This is my Azure portal. We need to open the app service, which is Clowntown app, the first one. Yes, so the 4th link you see is Diagnose and Solve Problems. That's the support center we are talking about, so we'll go there. Now my team has built a specialized interactive experience for you guys to troubleshoot an application in production. An application can have multiple problems. It could be down, and in that case you use the first tab that's there, which calls Web App Down. Your application can look for slowness in production, and then for that you go to the second type. Your application could be having high CPU, and for that you click the third type. Many times you get into memory problems even though your availability is fine, and you look into the 4th one. A lot of customers actually wanted to know why their application got restarted in Azure. So we cater to those customers. We are releasing one more thing called Web App Restarted, where you can actually know why a web application on Azure got restarted. The last one we have is Health Checkup, and we'll come to each and every one of the demo in this session. The right-hand side is again a list of tools at your disposal which you can use. The first section is a list of tools. If you want to look at perf metrics, you can click on metrics. If you want to look at live HTTP traffic, you can also view that. There are some FAQs which are well-known blogs, which could you can probably find solutions here for the common problems. If you scroll down, there is a resource center. Yeah, and then there are video walkthroughs quickly getting started, which will get you very quickly getting started in Azure. There is community links, which you can use in the bottom, yes, which has MSDN forums, Stack Overflow, and you can use that, and recent updates. Yeah. So a lot of times when a stack gets, they update their bits, you get failures in production. So you can use this links to actually know their stack updates. It could be a .NET Core update, it could be a PHP update, it could be a Java update. And we are in GitHub, so you can connect with us using the GitHub repo here. But first thing first, my PHP app is still down. I need to bring that up. So let's go to Web App Down. We'll just give it a minute to load. Okay. So this is my application. This is the experience that we give you for app error analysis. We have divided this experience into 3 sections. The first section you see is metrics. The second section, where you see that orange bar at the bottom, is observations. These are the things that system has found in your application which have caused your application to go down. The third section at the bottom is solutions. So system has actually used the observations and suggested certain solutions that we can use to bring our application up. So in this case, if you scroll to the top, you will actually see the availability of the platform is 100%, but my application is severely down. It's 0% right now. So that's not very good. So let's look at the observations. It calls out that my application is healthy. If you look at the first observation, it says my PHP app is getting a timeout. Now this is a very common problem that can happen. Let's look into view details to see what we can find. All right, so this is PHP log analyzer. The function of this analyzer is actually to look into your PHP logs, look into the errors, and give it to you on the platter. So if you look in this case, the first is still availability. The second graph is a PHP error timeline. In this case, we were only getting timeouts, and you can see a strong correlation when the application went down and the PHP timeout started happening. The third table here is actual stack trace, which we found in your log files. In this case, I'm hitting execution timeout on the PHP load file. And it happened, I think, some 170 times, which is not very good. So you see that how we are able to quickly identify a problem when the application goes down. But that's not all. We want to solve it. So let's go back to app error analysis. You close this tab. Right. So the solution that the system is actually giving me is to increase my timeout using Kudu console. Now, those of you who are not aware of Kudu console, it's a site control manager which comes up with your Azure Web App. So we'll open Kudu console here. It gives you access to your site content also. So this is my site Kudu console. It does an ADFS authentication on the app. So let's just navigate to our www root folder. And let's just update the .user.ini file. You see the max execution time I've specified as 2 seconds here. And just for quick mitigation, we'll just make it double, 4 seconds. Let's just save it. When I did a save, I don't have to do a production deployment because it's actually getting updated directly into production using this. Most of you use various publishing methods like VSTS or GitHub. You can also use that to publish your changes. So let's go back and see if this solved my problem. Let's hit a refresh. Yeah, it generally takes time. Let's do a hard refresh. Boom, it's up. So you see that how we are able to quickly mitigate this issue in production. And this is just one of the problems that can happen. I demoed a very simple case in this demo, but you can imagine a lot of other problems that can bring your application down. Solutions to these problems tend to be very hard, but with using Support Center, these solutions are minutes away and you can use it.
That's pretty cool. Actually, we debug down to the code level very, very quickly. That's very nice.
Yeah, but this was one of the simplest demo we had. With the next set of demo, we'll go into a little bit harder one. So app slowness. App slowness is one of those things which actually does not surface right on the face. Your errors will not be there. You will be having all 200s, but your application is sluggish responsive. Now, this is one of this application which we have in production, and if you try to browse to that application, look at that spinner. This is very embarrassing. This is very embarrassing for the developer, and it's very frustrating for the customers. This site generally responds in a second, but you can see that something has gone wrong today, and it just loaded up. Probably took like 20 seconds maybe. Let's try to debug this application in Azure Support Center. So now we go to Web Apps Slow tab, which is the second tab there. All right. The UI is very much similar to what we saw in Web App Down. The only change is the pivot is now performance in the top graph. You can see that we are plotting the 50th percentile of your response time, which means majority of your calls. And clearly something has gone bad, and there's a huge spike in the response time. I think it's over 10 seconds clearly. The system identified this problem. Let's look at the observations. Yeah, so what system identified is this application is using high CPU. Now this is a very common problem in cloud. What happened here is my application is running on one instance and it's burning CPU like crazy. Let's go to view details to see what else I can find. All right, this is CPU analysis. Just like PHP analyzer, this is CPU analysis. The top level is still performance because we came from performance view, but the second graph you see is CPU usage per instance. Now your application might be running into multiple instances in cloud. So this graph will actually show you CPU breakdown of every single instance that your application is active on. The third graph at the bottom is process level breakdown or app level breakdown on an instance. Now you may be stuffing a lot of applications on one instance. So this graph will actually help you identify which application is taking how much CPU on a particular instance. In this case, if you look at the second graph, clearly that CPU is spiking to 100%. It was around 80%, it took a spike. And it's very much, it's getting strong correlation with the performance problem also. So we'll go back and try to resolve this issue. So we scroll to the solutions. Now in this case, the system actually suggested me two solutions. Every application, let's first go and try the first solution. Let's just restart the application on that instance. So the system has restarted the application. Now every application is different. The symptoms are different. The cause of a performance problem could be different. So what the system does is it gives you a set of logical solutions to try. If the first solution does not work, we'll go to the second solution and so on and so forth. Now, another question that arises while solving performance issues is, this is fine for mitigation, but I really want to get down to the code level where the performance slowness is happening. So my team is actually working on putting a profiler right here in the performance view, and with a very seamless experience where we should be able to nail down to the code level of an application where the performance slowness is happening. So meanwhile, we tried the first solution. This time the second solution is scale out. What that will do is it will scale out your application into multiple instances, and the CPU will get distributed across those instances. So on the first one, let's just try to hit the site and see if that came up. So this was that embarrassing moment for me. Let's just see that now. All right, I think it was fast. Yeah, now it's responding very fast. So we are quickly able to mitigate this problem within seconds. One of the harder problems to solve, slowness, we are able to do that in seconds. All right, for the next set of demos, I'll hand it over to Praveen.
All right, let's talk about memory. Memory problems usually tend to be more complicated than CPU problems because unlike CPU, which is a unidimensional problem, memory has multiple dimensions that can go wrong. Imagine you have an application and there is a memory bug lurking around in some corner. It can manifest itself in various forms. Your page reads per second can skyrocket, your committed bytes can gradually keep increasing over a long period of time, or your physical memory can go all the way to 100%. In the new experience for memory debugging, what we are doing in Support Center is consolidating all of this information and presenting to you in a very concise form. Let me show you what I mean. Can we go to the memory experience?
Sure thing.
There you go. On the top, you see a chart. The chart is the availability, the familiar availability chart. But on the middle part, you see a consolidated report of memory. Thankfully, everything with respect to memory on this particular app is fine. But let me go through the details. Let's go to the page operations. What you see is the page operations that are happening on this particular process, and it's well within the bounds. This application, as far as memory is concerned, is working fine. But if you notice any time that the page reads per second skyrocket more than 200, then you have an issue. What happens is your process almost gets suspended, your requests start piling up, and bad things start happening. So you definitely want to watch out this specific metric, make sure it's never more than 200. So let's look at committed bytes. Now, committed bytes is the amount of memory both on the RAM as well as on the disk, the paged out memory together. If you have an application that is having a memory leak, this is the place to be. What you will see is you will see a very, very gradual increase over a long period of time, and then a crash, and then over a long period of time another growth. So you will see kind of a sawtooth pattern. So keep a watch for that on this particular graph. If you see a sawtooth pattern, it's a very strong indication that you've got a memory leak in your application. Let's look at the physical memory now. If you happen to have a lot of apps stuffed into one single app service plan, what will happen is all of these apps will be contending for memory resources, and the physical host will get overwhelmed. And whenever this happens, this is the graph that will show it to you. It will show you that the memory usage is peaking all the way to 100%. It means that the host is struggling. If those kind of memory problems happen, this is the graph that will explain it to you. Now, all of this data is fine, but you are mostly interested in how do I recover from this situation. The system is smart enough. If there is a problem that it detects is happening right now, it will suggest you some quick mitigations, things like restarting the application, the specific process on the specific instance, or it may suggest you scale out, or it may suggest you distribute your applications into a different plan so that the memory contention goes away. However, if the problem has happened in the past, it will suggest you a memory profiler. Now, memory profiler is a very interesting tool because it helps you identify in your code which are the parts which are causing a memory hog, and it will help you optimize your code. So as you can see, memory is a fairly complicated topic, and what we are trying really hard in my team is try to consolidate and concise and make it very, very easy for you to debug memory issues. So that's memory for you in a nutshell. Now let's move to the next scenario, a more common scenario, application restarts. When we talk to our customers, there is one common theme that comes again and again. People ask us, why is my application restarted? In fact, sometimes people ask, why did Azure restart my application? More with a blaming tone. So we took this feedback very close to our heart, and we did a research on finding out all possible reasons why an application restarts in App Service. It turns out there are many, many. I'll briefly describe the top few. A user can initiate a restart by virtue of logging into portal and hitting the restart button. The platform can initiate a restart when we are applying security patches to the host machines. Your application code can crash, and this can cause a restart. If your application is unhealthy, the auto heal feature that we have will detect that your application is unhealthy and try to make it healthy by inducing a restart. So at a high level, there are many reasons why restarts happen, and we are trying to be as transparent as possible in exposing all of this rich information to you in our new restart troubleshooting experience. So let me show it to you what I mean. Let's go to the restart experience. Yeah, on the top you have a time picker. If your restart has happened a couple of days ago, you can go back in time. However, by default, the current date is selected. In the middle, you have a time chart. The time chart explains you when the restarts have happened, which means if your application experienced a restart, it will show up here. Notice the legend on the top right. Remember, I told you there are many different reasons why restart happens. Application-induced, user-induced, or platform-induced. Those things will show up on the top right of the graph. On the bottom part, we have a very important summary, more detailed information about why that specific restart happened. The font is very small, so let me read it for you. What it is telling is, in the last 24 hours, there have been 2 user-initiated restarts. One was by the virtue of a person logging into portal, and the second is by doing an environment variable update. So that's restart for you folks. It's a complicated topic, and we have tried to simplify as much as possible. As you can see, we are trying to be as transparent as possible in the system, and so that we all can benefit out of it. So with that, let's move to the next part of the presentation. So Shekhar, let's go with the app check.
All right, guys. So let me share a very interesting story that we have experienced in our office. There's this team that sits next to us, and they have their services deployed into Azure App Service. Every time they do a deployment to production, they go into the old diagnose and solve, and they do clicks on requests and errors to see if their application is fine. They look into slowness to figure out whether the application latency is perfect. They check the CPU usage and memory usage to see that after production deployment, they have not regressed anything. Basically, they're trying to answer one simple, very basic question: is everything fine in production? Now, for that set of customers, we have done something very special called App Health Check. Now, if you go back to the demos again, and let me just quickly demo that to you. So if you go back to the demos and just go to the home page, so this is the interactive experience that I was telling you about. So the system is asking whether you want to run a health checkup or not. Let's go ahead and click yes. All right. So what system is doing is it's collecting different signals and providing you in a very consolidated report. So there you go. The report is out. You can see that system has checked about, let's just scroll a little bit up. There we go. So the system has actually checked for requests. It has checked for, and the marker there next to the tab, you see if it's green, it means everything is fine. It could go red, which means there is something issue going on right now. And if it's a yellow, it means there was something issue going on in last 24 hours, but right now everything is good. So right now everything looks very perfect. So the requested error, the graph actually shows you the various HTTP status codes. The second tab is performance, where it shows the latency of your application. I think it's touch over 2 seconds, which is very good. 2 milliseconds, sorry, and this is very good. The third tab is CPU usage, which actually shows you the CPU breakdown per instance. And in this case, there was a spike, probably because when we did a deployment, but everything seems to be fine. And then the fourth one is memory usage, which shows you the physical memory used across instances where application is running on. So no more multiple clicks just to answer this very basic question, is everything running fine on production? You can use this report and just get your answer there. My team is also working on to export this report, so you should be able to download this report and use it in your mails and those kind of things. Let's go ahead with the experience that this system is offering. So it says whether you like the health check report or not. Let's just say yes for now. All right. And now it wants some feedback. So if you want us to add more signals onto the report, things that cater to you, we can very well add that. We just need your feedback. With that, I will like to go to my next section, which is Connect with Us. All right, so Support Center is still an evolving system. We look into problems and we try to provide you solutions. But every application is different based on stack, the way they behave. And that's where we need your input. Try out Support Center for your applications when you see issues. If there is something that you don't like the observations or the solution that we are providing, or if you need some new features from us, just connect with us. There are various ways you can connect with us. One of the ways we just showed you on the home page. The second way is when you open the tiles and we show the observations. There are feedback channels that you can send your feedback. And we are on GitHub, so you can open just a new issue on us and we'll get onto it. And that's how we'll probably make the system even better. With that, before quickly wrapping up the session, I'd like to open the session for a quick Q&A.
So if anyone has a question, please approach the mic if you can, or I can repeat the question as well.
Yes. Hey.
Is there command line?
It's audible, yeah.
Is there command line support for the diagnostics?
So everything is APIfied. There's an ARM API that you can use. Going forward, there would be an Azure CLI command that we can probably surface it to, but you can hit the ARM API and you should be able to get the data. Anyone else?
So a quick question back to you. Are you thinking about automating this particular diagnosis?
Right, so the use case you presented was I deploy an app, is it healthy? So my brain goes to I deploy an app and then bake into the process. Query CPU, query memory, if it comes back of a certain threshold, take action.
That's a pretty good use case, I would say. Yeah. Yeah, definitely.
Yeah, I think that's a very common use case that everyone wants to get to, and that's why we have APIs. Shortly, we probably will also have command line. So, anyone else? All right.
All right, let's
Probably
move.
we should go to conclusion then. So today we saw in a quick demo that how App Service Support Center can actually look into your application problems and help you suggest some solutions. If your application is down, you need to use the Web App Down tab. If your application is performing slow in production, which is one of the harder problems to detect, you need to use the Web App Slow tab. And if your application is getting high CPU or memory, you need to look into the high CPU and memory tab. And if you want to know why your application got restarted, you probably want to hit the 5th tab. To answer this basic question on if my application is doing fine in production right now, just use the health checkup report that we have, and it will give you like this consolidated report. Now, if you see in this, this is one of the screenshots that I took for my application, a production application, which actually started going down when we deployed, and the request and error actually went bad here. And last but not the least, we are on GitHub, so do connect with us to make the system even better. Just open an issue for a feature request for any bugs if you want to, if you're not happy with anything, and we'll get back to you. So with all the efforts that my team is doing, we are really trying to give you the self-serve ability in Azure to help debug your application in production. Thank you very much.